let's investigate how a loudspeaker works. So a loudspeaker comprises of an alternating current power supply, a permanent magnet that sits behind a coil of wire wrapped as a solenoid around iron, and a cone. Okay? And what happens is this coil of wire vibrates when alternating current passes through it backwards and forwards, and the size of the current affects the size of the vibration. The direction of the current changes the direction of the vibrations. This solenoid interacts with a permanent magnet that's built behind the loudspeaker in the first place. And due to the movement of this, the vibrations cause the cone to vibrate, and that causes pressure changes in the particle, which causes sound to operate at a longitudinal wave. So let's summarise this. A loudspeaker requires current to be able to change direction so these vibrations can occur. Therefore, it needs to utilise alternating current because the electrons can move in a positive direction and in a negative direction too. Going through step by step, this circuit, where we've got the red wire wrapped around as a solenoid, the circuit is connected to an alternating current power supply. The current in the electrical circuit varies in direction because it's alternating current. This current passes through the coil, and that induces magnetism in the coil because it's a solenoid, so it behaves as an electromagnet. The coil experiences a force as this solenoid has now become magnetised, and it interacts with a permanent magnet. It's really important when you're discussing this that you talk about how the solenoid has become an electromagnet and it's now interacting with that permanent magnet. The direction of the force depends on the direction of the current. So if it's going that way or that way depends on which direction the current is going in. Reversing the direction of the current reverses the direction of the force. The size of the current affects the size of the force. So if you turn the loudspeaker up, you're increasing the size of the current to make that force value higher. Because the coil is vibrating, the cone vibrates, that causes pressure changes in your particles, and that's what causes the sound to be emitted. Headphones work in the same way and interact with your eardrum.